Good evening, Poohske here. I'm here to talk about this bike that I converted into an e-bike for under $50. Everything's brand new. Here's a close-up of the two motors. It's a friction bike, but typical friction bikes usually apply friction on the tire. This one applies it on the rims, like brakes would, but in reverse. Those are the two controllers, and this is a servo tester that I hot-wired so that I could run off a button to switch it on and off from the handlebar. Now that's a push and click, and it'll stay running until I click it again. And I have one battery that I put together hastily, so it's, I believe, 2 in series and 3 parallel, which what that means it's about 7.4 volts and about 6 amp hours. And that's enough for me to go 15 kilometers, with me assisting, of course. You can see the motors as they're activated, they press up against the rim. And at that angle, they're trying to climb up the rim, giving it more torque the more resistance it has. And then when it's not turned on, or when it's deactivated, you can see the motors pull away from the rim. And that's what I'd like it to be, because I want it to turn off whenever it's not being used. And it saves the motors and saves a lot of things. But even if the motors are still touching, it's not a whole lot of drag on them. So you can see how I use rubber stops on the motors. They were uneven in the beginning, but after running it a few times, the rim smooths it out pretty quick. And you'll see here soon. You'll see that small amounts of rubber slowly peel away. It's like a clutch if you think of it in terms of cars. The more gas you give it while it's standing still, the more rubber or the more clutch it burns off. This is how loud it is. It's about 53 decibels. Considerably quiet when you're outside. It shouldn't disrupt your surroundings, and you shouldn't notice it much. You can hear it in the video here because I'm driving in a suburban area. It's quiet, and even then it's not too loud. I'm not pedaling at all. I might start pedaling here in a bit, but it pushes you along. It's an assist more than anything else. So when you activate it and you're pedaling, it feels like you shifted gears, like 2 gears, if you want to get an idea how that feels. And if you don't pedal at all, it still pushes you along, about a light jog pace, not particularly fast. But these motors are 1000 kV, meaning they spin 1000 times for every volt a minute. And their system's about 7 volts, so it's about 7,000 RPMs a minute. And that's how the RC's motors are measured. They don't have horsepower per se. The lower the kV, the more torque it has. But this was meant more to help my top speed. Here's another picture. It was designed more for me to be able to go long distance, save battery, and I can pedal pretty fast, so this is just supposed to help me get faster. I never designed it for me to accelerate at a crazy speed or make break speed. I'm sorry, you're gonna see me pedal a bit just so I avoid this car. It picks up pretty well when it's flat and there's no wind. It really doesn't need my help. Understand, this whole system was $50. So the idea behind it was cheap, affordable, and useful. And not just that I needed to last about 10 miles distance. So I wanted to, so that everybody can make it. And this is the version 2 of this model. I went through a few different designs, and this one was the one that yielded the best results. And this model I'm going to convert into a 3D printed model so that it's easier for people recreate. Or you're going to see me pedaling with the motors together. And I'll give you some statistics of our speeds. This is on the road leading up to Shibuya, Tokyo. And like I said, it feels like you just shifted 2 gears whenever you turn it on. Like it's that much easier, even though you haven't, it's just easier at the same speed. It's not noisy, you don't see heads turning because of it.
Thank you for watching.
This is my average speed was about 21 kilometers, and the top speed was 40. And the distance was 15. I know it says 57, but it was just 15 kilometers distance. And this is me going to work. And again, 21 kilometers average, and then it's 42 kilometers top speed. Same things, different names. 46 kilometers top speed, 17 average. This one's 16 kilometers average, 50 kilometers top speed. This was on fresh batteries, just charged. It was a short distance, it was under 4 kilometers distance, and it was me just having fun. There's a map of Shibuya to Shinjuku, just so you have an idea of the distance and the location. You can see that there really isn't much of a hill or anything for me to pick up speed. It's just basically a straight shoot away, and there was no wind. And I got all green lights. And with that, thank you for watching that. Now here's the 3D version I'm making to recreate what we just saw. And this one's going to be a lot easier to recreate because it's measured out. Well, not this one per se, because I tried this one out and it's a little far from the rim. It needs if it's flat, it doesn't give you as much torque. It needs to be almost to the point where it's going to run into itself, and there's an angle that's ideal, and it's not quite there, so I'm remaking it. I'm actually making another top for it to replace this guy, and instead of it being on the bottom bracket, it's going to be on the top bracket, and it should be a more ideal angle. It should have a better performance for us. I'll show you a short clip here at the end, but I should have that up and running probably in another hour or so. And I might test it out even though it's 4 a.m. But either way, you'll have something to look forward to tomorrow. That system is my baby, per se. I really like the idea, I really like the concept, and it's an easy, simple idea. Friction has been around for a while, but I really think this has a lot of possibilities, especially if you don't want to modify your bike too much. If you would just want to add one part, not wear down your tires, and have a considerable boost, I think it's going to be fun for everyone. But I'll leave you at that, and then tomorrow I'll go ahead and post a video with me riding around with the new system, or with the new 3D printed parts. Thank you very much. Have a good night. You see, it's just not gripping the rim. It's spinning, and it's all the same parts. And even though right now I only have one motor attached, it's just not gripping the rim and pulling itself up. There's ways to fix that, but the best idea is to redesign it slightly so that it's at a better angle, so that it grips quicker and there's more torque against the rim. Otherwise, it needs something assisting to push it towards the rim, and I'd rather have it pull itself back up. And that's it. Have a good night.